guess you guys are here to talk about products, fractions, and like terms. Cool. Learning intentions for today are to solve and simplify algebraic products and fractions using the correct notation and by collecting like terms. Let's kick into it. So let's look at an example. Here we have 3 times 5x times x. And first thing is, it's really important when you're writing this in your book, get into the habit that the unknown variable x, do it as this cursive. So often when I draw it by freehand, I draw it almost like 2 C's back to back. So it's really exaggerated to make it really clear. And your x is just your standard straight cross. It can get confusing and people can make mistakes there if your x's look too similar. And then they go, oh, look, sick. We've got 3x, 5x, xx. Like, that's like 15, lots, and 4x. Nah, it's all bad. So make sure it's clear. So we've got this example. What it's saying is 3 lots of 5x times by an x. So we can actually combine this and go, well, 3 times 5 is 15. And then x times x, ooh, can we do that? Yes, we can. It's an x times an x, so it's an x squared. So this will become 15x squared. That is combining it into a nice, tidy, lazy to write, which is always the goal, mathematical algebraic expression. So we're going to have some practice. Simplify the following products. I'll do the first one for you, and I'll just show you what we're looking at. So anytime you have 2 times 5x, remember this is 2 times 5 times x. So the order is not important, but we can definitely multiply the 2 and the 5, and the x just tags along. So the answer would be 10x. I'll leave the rest for you. The only thing I'll say is be careful with things like negatives and negatives and positives and negatives, because we've talked about that. We know what they do. Be careful with that as you multiply. Answers will be up in 5 seconds for you. Pause the video, have a go at these questions.
Yeah, buddy!
Answers above. Check your answers. Make sure you got them all sweet. Next set. Now we're looking at solving fractions by plugging in a value. So in this case, they've said if the unknown variable a is 3, b is equal to 2, and c is equal to 6, solve these fractions to figure out what the numbers would be. So it's just a plug and chug style, which just means for a, for example, c is 6, so you have 6 on 2. We can simplify that down a bit. 3 on 1. 3 on 1 is just 3 because we're lazy in maths. So 3 would be my answer. So repeat this process for the highlighted questions here. Answers are going to be up in 5 seconds. Pause the video, have a go at these, and then get ready for some answers.
Yeah, buddy!
So check your solutions above. Make sure you got them all correct. The next thing to look at is this concept of the terms being separated by a plus or a minus sign. The sign is included in the term. That's important. So for example, if we look at something like the negative 2x here, this negative is part of the expression. It is minus 2 times x times y. So that's why if you multiply this number by something else, it's important that the negative comes along for the right. When we talk about a like term, we're talking about something that has the same variables or the same letters to the same powers. So in this case, for example, 3 times x times y and minus 2 times x times y are like terms because they're both xy's. So the unknown variable is xy. The numbers in front, which we call the coefficients, the word in front of the variable, coefficient, is different. But that doesn't matter because I can just add and subtract these now. Because they're like terms, I can say, well, I've got 3 lots of this thing, and I subtract 2 lots of this thing, I'm going to have 1 lot of that thing. But in algebra, that thing happens to be xy, whatever that is. And xy could be an apple. Xy could be a number. XY could be the secret to life, the universe, and everything. It doesn't matter. It's just a substituted letter. However, if I look at something like x squared and 3x, they are not the same because the powers are not the same. So x squared is x times x. I can't add that to 3 lots of x. They're not the same thing. So they're not like terms. So that's the biggest trap there, is only when they are the same power and the same terms can we combine them. In this example here, we're looking at collecting like terms, which if we had something like 2a and we subtract 3a, then we're going to have negative a. You could say negative 1a, but remember, we're always lazy in maths. We don't write things we don't have to write. I love to use algebra and just think of an actual object. So when we say a, let's call it an apple. You have 2 apples. I take away 3 apples. How many apples do you have? You've basically got negative apples, which doesn't really make sense, but it works well with currency. You have $2 and you now owe me $3 or pay me $3. How much do you have? You're in debt $1. So you are negative 1. In this case, that dollars, that apples is a, and that's our algebraic expression that we're talking about. So there's a couple of different examples here for like terms. If you want to have a quick look at this, we've got 5y minus 2y. Fair enough, gives us 3y. 2a minus 1 plus a. We can't do anything with the 1, but we've got a 2a and we add an a, so we get our 3a minus 1 tags along for the right. Here we have our like terms again. That's an mn and an mn. So we had 1 of it. We subtract 2 of it. Ooh, why did we get negative mn? That makes sense, right? Plus 1, minus 2, you go 0, negative 1. Check. It's good. Don't make the mistake of thinking this is like a negative 3 or something like that, because you've got to remember your number line. You go 1, 0, negative 1. So that's our cycle. And then the last one, a squared minus 4a, we cannot simplify because they are not like terms. Let's get some practice. So here we're simplifying by collecting like terms. Answers are going to be up in 5 seconds. So pause the video, have a go at these questions.
Yeah, buddy!
Solutions are above. Another example is for simplifying fractions with algebra. Just like we've seen with normal numbers, if we have a like term in algebra, we can simplify it. In this case, we don't need the powers to be the same because we're factorizing it out. And a fraction symbol, just like in a multiplication symbol, we can factorize things out. Pluses is a little bit more tricky. So here, if we had a squared on a, remember from our previous index section, that is a times a over 2 times a. So we can cross out one set of a's from above, as you see here, and we've simplified to a on 2. In this case, we do the same thing, 6a times b over 3 times b. With b's cancel out, the 6 and the 3 can be simplified to a 2 on 1. We have this 2 times a on one bit, and we can just rewrite that now in our algebraic expression, nice and lazy, as 2a squared. The last one is the a plus b on a. This cannot be simplified because we've got a sum on the top, not a product. We can only simplify fractions where there's a multiplication there, not addition, because this is not the same as this, so we cannot cancel that out. So that is as simple as it can be. Let's practice it. So in this case, yes, there are a few. No apologies. It's really important to get the practice with these and get into the habit of being quick at factorizing these. All of these, as you can see, are products, so all can be simplified to some level. Notice that these have pluses and minuses. These are quite difficult. However, you may notice that there are some like terms around. You might need to pull out a value here. So for example, let me look at a for you. First you say, okay, well they're pluses, so I can't do anything, right? Just can't do it. Can't do it. However, you notice you've got an x plus 4 on the bottom. Can I create an x plus 4 on the top? And hopefully you can look at it and go, hang on, it's 2 times x plus a. I could factorize that top line, pull out the 2, and have 2 bracket x plus what would be on the inside? It'd be 4. So I'd have 2 times in brackets x plus 4, but then I've got an x plus 4 on the bottom. So now because I've got an entire expression in brackets top and bottom, that can cancel out, and I'll just be left with my little 2 at the top. So try that for yourself. Write out that description that I've just done to visualize how that would work. And in a lot of these questions, that is the goal. Find a way to factorize it into something in brackets that matches something in brackets on the bottom, and then you can cancel out the entire thing in brackets. Otherwise, if it's like the example we saw before, where it's just this, there's nothing we can do to that. In these examples, in a lot of these cases, there will be something we can. So pause it, have a go at these questions. Answers will be up in 1 second.
Yeah, buddy!
So check your answers above. If you made a mistake and you're not sure where you went wrong, this is the time to speak to the person next to you, cross-check, come speak to me. It's really important that you don't just move on if you haven't got it right and you don't know why. Success check. Ask yourself, can I accurately solve and simplify algebraic products and fractions using the correct notation and by collecting like terms, which is all of the stuff that we've just done. If you are confident to do that accurately, even with those ones at the last section we just saw with the plus and minus sort of stuff, tick in the box, you're good to go. If not, you know what to do.